Hello friends, welcome to my Hariharan and Express channel. Today I will discuss another topic, that is Boolean algebra with certain postulates and certain examples. How to create Boolean algebra, or what is the rule and regulation for Boolean algebra. So based on that different rule and regulation are required based on different category of elements. Okay, whenever they will analyze of a particular category of sets or set of values like this. Whenever I go through that Boolean algebra, we will see how different postulates or axioms or rules and regulation are used or are defined through different ways. That is, we will see that actually it is one kind of a set theory. We can also consider different sets we will consider, and some elements also we will consider to define Boolean algebra. So Boolean algebra, like any other deductive mathematical systems, that may be defined with a set of elements or set of elements, a set of operators, and a number of unproved axioms or postulates we can consider like this. And a set of elements is an collection of objects. We know that set of elements means it is a collection of objects having common properties. Okay, not randomly we can take as a set or a number of objects. It has some common properties. If we say let S is a set, for example, S is a set. Okay, S is a set, and X, Y, Y are two objects. Okay, we will consider, suppose X is a set, X, Y are two objects. Then we can tell as like X belongs to S. Suppose X belongs to S means X is a member of X. Yes. Okay. X is a member. We can write X is a member of S. Okay. If we suppose X is not belongs to S, for example, if S is not belongs to S, that means X is not a member of X. Very simple concept of set and elements. X is a S. Suppose X is a S means X is a member of S, and X doesn't belongs to S means X is not a member of S. This is the basic concept. So you can tell these X and Y are objects. Different objects we can consider. That objects also define this set, S set. Okay, in this way. So that set defined in different ways. According our requirement, we can also define. Like suppose a set with a denumerable number of sets specified by certain braces. For example, we can take like A is equal to, or A is a set having 1, 2, 3, 4, for example. Okay, that indicates the elements of set A, that is specified a certain number 1, 2, 3, 4, like this 1, 2, 3, 4. And see, A is a set having certain number 1, 2, 3, 4. Okay, now we can tell, suppose any elements as a member like 1, 2, 3, 4. These are members of A. These are the elements. We can tell is a element. A is a set. A is a set. A 1, 2, 3, 4 are elements. So if 1 belongs to A means we can write 1 belongs to A here like this. Okay, or 2 belongs to A. But here you see, suppose 6 not here, you see, because A is a set 1, 2, 3, 4, 6 is not there. So 6 doesn't belongs to A. That means 6 is a element or member of a member which is not available in a set, but 1 2 3 4 are members which are available in a set A. So elements we can tell as elements also, a 1 2 3 4 are elements of set A. Okay. Another way also we can define, like a some certain operator also we can define, like a binary operator is defined on a set S of elements, is a rule that assigns each pair of elements from S unique element from S. Example, whenever we apply any kind of operator doesn't matter, that is we can tell as a binary operator, means in between two elements one operator we consider. Okay. For example, addition operator, suppose here is addition operator. It is addition operator in between two operand, like that operand also consider as a one elements, like a plus b. Okay, we can tell as a plus b or a multiplied by b. So this addition subtraction is a operator, we can tell as a operator. Okay. And a b are two elements, a b are two elements of a particular certain set. Okay. So question is, whenever you apply this operator on certain elements, what is the resultant value? Then that resultant value is belongs to that set or not, that we have to see. Okay. For example, C is equal to A plus B. For example, A, let us consider a clear example. Let A B belongs to S. Okay. And C is equal to A plus B, and A plus B belongs to S. Okay. A plus B belongs to S. If there, that means C belongs to S, because C is equal to A plus B. For example, suppose addition operator we will consider, like plus is addition operator we consider. So two elements A and B, add that number which is equivalent to C. If C belongs to S, then what happens? Binary operator will satisfy. Okay. If it not there, it is not, that is a binary operator. Okay. Once again, suppose A B belongs to S, we satisfy that binary operator on S. Suppose C is equal to A plus B, binary operator, addition operator apply on the set S. If C is equal to A plus B, C should be belongs to S, then binary operator, suppose here binary operator should be, binary operator plus should be satisfied in S. Then we can tell as a binary operator which is belongs to binary. When I apply the binary operator, the result also belongs to S. Then we can tell as a this is binary operator if all values are satisfied. Okay. Like suppose plus is a binary operator satisfied to S, then A B belongs to S and A plus B belongs to S, then binary operator will satisfy. Otherwise we can tell as it is not a binary operator. Okay. That is a plus is not a binary operator, because the elements evaluated through this binary operator not satisfied of same set S. A plus B belongs to S, but not satisfied means suppose A plus B doesn't belongs to S, then binary operator, this is not binary operator. Okay. Binary operator belongs to S, belongs to S. Okay. Which belongs to, which belongs to S. This is the basic concept. Okay. If it belongs to S, means it is a binary operator on set S. Okay, this is the basic concept. So different postulates also we can define. How to define? We will see how to define different postulates. The postulates actually it is a one kind of or a different kind of rule and regulation. Okay. So the postulates of mathematical system form the basic assumptions from which it is possible to reduce or deduce the rules, theorems, properties of the system. And the most common postulates used to formulate various algebraic structure. We will discuss what are the algebraic structure through various postulates which is formulate different structures that we will see. Okay. So now we will discuss a different kind of algebraic structure which is satisfied a different category of postulates. How those postulates we will see one after one. First of all, we see that is a closure. Okay, you see closure property. So closure property is very simple property. Like whenever we will take any kind of elements of a particular set, when I apply any operator, that is resultant value also belongs to that set, then we can tell as this is a closure. Okay. So like suppose that is a set, S is a set which is said to be closed or closure. Set is a closure with respect to binary operator. Closure with a binary operator. That binary operator we can consider as our choice. If every pair of elements of S, the binary operator specifies the rule that obtaining a unique element of S. Okay. Like we have already discussed just before, that is whenever apply any kind of set, the any operator use, the resultant values also belongs to that set, then it will be satisfy that operator, binary operator, otherwise not. Okay. We will see that which what are the different examples. For example, n is a natural number. For example, n is a natural number, 1, 2, 3, 4, like this different natural numbers we will consider. Okay. And let us consider the this is the binary operator. Okay, binary operator. This binary operator just apply, that is binary operator means that is addition binary operator we just apply on this particular natural number. We will see how it is used for closure rule. Okay. If a b, for example, a b belongs to n, then a plus b belongs to n or not, we check it. Okay. A b belongs to n means a b are elements which are natural number. So obviously a plus b belongs to n, because suppose c is equal to a plus b, then c belongs to n naturally, because addition of two numbers, natural number, that is belongs to n. Okay, it is obviously that is true, that is it is absolutely true, because addition of two numbers also natural number if two numbers are natural. So the set of natural numbers is closed with respect to binary operator. Okay, this natural number is closed, natural n is the natural number close to, okay, close to binary operator, that is plus. Okay, it is close to binary operator plus, but not other operator, it is only close to operator plus. And a multiplication also we can use, that plus addition and subtraction, that operator also we can use. But if this natural number use the operator subtraction or a minus, then it is not satisfied. Okay, this natural number is not satisfied for minus, because minus value whenever you consider, suppose value we can consider natural number is 1 2 3 4 like this. Okay, not normally if we go through there is two number, one is 2, another is 4. Okay, 2 4, then if we minus or a subtraction operator we will consider, so 2 minus 4 doesn't belongs to n, that is minus 2 doesn't belongs to n. That means natural number doesn't satisfied on operator minus. Okay, natural n doesn't satisfy on negative operator or minus operator, it doesn't satisfy. So it is not closure on minus or that is subtraction operation. Okay, only addition or multiplication it can be used. So closure property is satisfied on a set where it is close to which operator. Okay, that we will see. So n is a closure or closure with a certain property, certain binary operator, that is addition. Okay, addition and multiplication, the two operator it will satisfy. So n is a natural number which is close to the operator addition and multiplication, not that is subtraction. Okay, like this we can define different properties. Okay, so now you see other part also. This is the first is a closure property. Next we will see another property. Here another properties we can tell like a commutative. Okay, there is a commutative. Another part is a commutative. So commutative properties, how it is satisfied. Or second one also you can write associative. Different rules are there, doesn't matter, no order is there. So commutative or commutative, that property is satisfied, or a commutative law we will define. How? A binary operator is a binary operator. Suppose binary operator star, for example, this is a binary operator. We will consider on set S. On set S is said to be commutative whenever x commutative with y, x into y, or x operator with y is equal to y operator with x. Okay, for all x y belongs to S. Any elements we will consider, that is x and y belongs to S, then we see that x commutative with y. Okay, x multiply y, y multiply x, like we different ways, x plus y, y plus x, x into y, y into x, but x minus y doesn't equal to y minus x. So here some properties we satisfied. This operator, that is plus and multiplication or multiplication operator, okay, satisfy on commutative law. These two operators satisfy on cumulative law. Other minus not satisfied, and division also not satisfied, doesn't satisfy on cumulative. Okay. So next is similarly we can tell like associative. Okay, associative means that is what is the associative with certain elements of a particular set? A binary operator, okay, we can tell binary operator, suppose this is a binary operator on a set S, okay, is said to be associative property. Oh, sorry, here we can write it associative law. When the binary operator star on set S is said to be associative, then we find the solution or find the postulates in this way: x with y with z is equal to x y with z, like this. X y associated with z, or x is associated with y z, like this. First of all, associated. Here is what happens: z associated with x y, x associated with y z. Okay, we can tell like this, where x y z belongs to that is S. Okay. Here x y z belongs to S. So which operator, which operation also we can define, like addition satisfied, also multiplication satisfied, both are satisfied, but division and subtraction not satisfied for associative. Okay, so like this different concept also we define. Next, similarly we can tell identity element. Okay, identity element. Which one the identity element? Okay, we'll see which one identity element. Okay, so now we'll discuss regarding on identity element. Identity element, similarly, S is a set. We will consider identity element with respect to binary operator. Binary operator also we will consider. Then identity element, suppose E belongs to S. E is the identity element. For example, it is a identity element. Okay, identity element. This identity element belongs to S. Then if this identity element will consider on binary operator this, then E identity element X is equal to X identity element with the certain operator, this star we can tell out multiplication, addition, like this. Okay, then which is equivalent to X identity element, when I multiply or addition, then same value we can get it, and where X belongs to S. Okay, where X belongs to S, X belongs to S. Whenever any identity element we consider, whenever operate with a certain operator, then resultant value is same. There are no changes of resultant values. So we can tell as a identity element. For example, we can tell like x plus 0 is equal to x, or 0 plus x is equal to 0. We can tell, sorry, x plus 0 is equal to x, 0 plus x is equal to x. Okay, x is any number, means any integer we can tell, no problem. So identity element are defined in this way. Okay, E is a identity element. Whenever that is add, multiply, having certain elements of certain set, we can get same element. The x is a element. When multiply or addition with this one, then it will be same element we can get it. That is the identity element. And another is inverse element. Okay, inverse role. That is here is a 4, 5. Here is a inverse. Okay, inverse rule. Inverse rule means what happens? What is the operator we will consider with a certain, similarly S is a set, certain operator we will consider, and certain rule also defined, like we can tell x y belongs to S, then we can tell x with y with a certain operator y is equal to E. Okay, if this particular value is defined this, then we can tell as it is inverse. X with a certain operator y is equal to E value. Okay, then we can tell as inverse. That means x is the inverse of y or y is the inverse of x. Okay, we can tell a very simple example. Suppose E is equal to 0, star is equal, suppose we consider addition. Okay, addition, then what happens? X plus minus y is equal to 0. Okay, x plus minus y is equal to 0, or other way also we can define x negative of a. Suppose a is a integer, negative is minus a. Okay, so a plus minus a is equal to 0. Okay, x plus minus is equal to 0. In that case, what happens? It is the inverse. A is inverse of minus a. Okay, a is inverse of minus a. A is inverse of minus a. Minus a is inverse of a, where both addition of that two number is 0. Okay, so we define in such way that x some certain operator with y is equal to E. E is the identity element. Identity element may be 0 or 1. We will consider. It is one example we can consider. Okay, so if addition point of view consider, a is inverse of minus a, or minus a is inverse of a. Both when add is equal to 0. Okay, and a multiplication concept also we can take a into a to the minus 1 is equal to E. A is inverse of a minus a to the minus 1, or 1 by a. A to the minus 1 is the inverse of a. That is equal to also we can consider. That is for inverse rule. Next is distributive. Okay. Next is a distributive. What is a distributive? Distributive means we use, and a distributive is distributed among elements. In that case, what happens? We will use two operator. One is for example star operator, another dot operator. Okay, these two operator use for a distributive. So two operator we see same. Suppose set, we can say the two operators star or dot are two operators on set S is said to be distributive if x star y dot z, okay, is equal to x star y dot x star z. Okay, x star y dot x star z. So we can tell as it is a distributive. It is simple way we can define in a different ways for Boolean algebra in a certain rule. Whenever analyze a different we can also use. Sometimes what happens, reverse of that particular rule also you can change here distributive, like x dot y star z is equal to x dot y star x dot z. In this way also we can consider different ways we can consider this distributive rule. Okay, so these are the common postulates under Boolean algebra. Okay, and that Boolean algebra also very famous for different application. We will see that different application how it is defined. Later we will see. Okay, again I will see from this Boolean algebra also define another category of postulates, that name is Huntington postulates. From Boolean algebra it is defined Huntington postulates. Let's see how Huntington postulates is defined. Okay, Huntington, that is a Hunti. Huntington postulates. This Huntington postulates is also derived from Boolean algebra. Okay, very simple way it is defined. So Boolean algebra is an algebraic structure defined by the set of elements, suppose B, and two binary operators. Here what happens, two operators are used, that is two binary operator, one is addition, another is dot. Two binary operators are used, provided different postulates, which we can tell as a Huntington postulates. Now we see that what are those postulates or rule under this Huntington. First one, you see closure property on this Huntington. Okay, the structure is closed with respect to the operator plus, please see that, plus operator. Okay, plus operator and dot operator we use, that is a closure property. Closure property on addition operator and multiplication operator, which very simple way we can use. Okay, second one is that is a identity element, also we can create identity element. Okay, how it is defined? Identity element of, let us consider 0. 0 is the identity element with respect to plus. Okay, that is a identity element is 0 on plus. Okay, this is one kind of, because we have defined, we have to define, that is a two operator, addition operator and multiplication operator for Huntington postulates for different properties. One is closure property, very simple. Addition and multiplication also we can use. Previously also we can use, very simple way, there is no problem. Okay, like for example, A B belongs to S, then A plus B belongs to S. Okay, another is A multiply B belongs to S, that is closure property, we have already discussed. Okay, so identity element 0 on addition operator. Okay, similarly another also that is, it is for addition operator, very simple way you can consider, like x plus 0 is equal to 0 plus x is equal to x. Okay, where x belongs to S, that is you can consider for identity element on x. Another one also identity element on dot operator. In that case, very simple way you can consider x into y, 1 is equal to 1 into x is equal to x, where x belongs to S. That is also we can consider. Okay, that is a Huntington postulates. Next, similarly another element also we can define, that is a commutative. Commutative law. In this commutative law, with respect to similarly addition and multiplication. Okay, how? Very simple way, that is x belongs, x plus y is equal to y plus x. Okay, both are belongs to where x and y belongs to, suppose S. X plus y is equal to a plus, that is x plus y is equal to y plus x on addition operator. Okay, if we go through another, x dot y is equal to y dot x on dot operator or a multiplication operator, that is also we can do. Okay, x plus y, y plus x is on addition operator, x into y is equal to y into x on multiplication operator, that is also we can do. Very simple way. Next we can see another operator, that is distributive. distributive operator, very simple operator we can also consider. Both also we can apply on this like a dot operator as well as a addition operator, multiplication operator as well as a addition operator. In that case, what happens? We can write in this way: x dot y plus z is equal to x dot y plus x dot y, x plus x dot z. Okay, that we can define. One case. Another case, x plus y dot z, also we can define x plus y dot x plus z, that is also we can define. Okay, so different ways we can define this kind of operator. Okay, so now we see what is the concept of the different parts of Huntington. Another case also we can define like a complement of x. Okay, we can tell as a complement of x. Very simple way we can define. That is a complement. Complement x we can define, but here is another is identity element also we can define. Okay, based on that complement, like x plus x complement is equal to 1. Okay, another is x dot x complement is equal to 0, obviously. Okay, this kind of a concept also we apply for Huntington postulates. Okay, x belongs to, suppose x belongs to S, complement also belongs to S, then we can see that is x plus x complement is 1 and x dot x complement is 0. Normal concept, Boolean algebra concept. Okay. Next, another concept is that there exist at least two elements. There exist at least two elements x, y belongs to S, then such that okay, x doesn't is equal to y. Any element will consider that is unique element, not repeated element. If repeated, that is considered as a unique one element. So x doesn't is equal to y. Okay, this number of elements or this number of postulates we will consider for Huntington postulates. Very simple way I defined this Huntington postulates. Okay, so now we will start the application, various application of that is Boolean algebra or other concept. Okay, Boolean algebra, Huntington postulates like this. Now we will apply the different application or certain example we can consider. Let us consider two values of Boolean algebra with certain example, like let b is equal to 0 1. Okay, b is a set, that is a 0 1. Two elements we consider. Let us consider two elements. Okay, now we apply the binary operators, that is addition and dot or multiplication on these two elements of set B. Then we see that what kind of result we will apply through that Boolean algebra. Okay, let us consider x and y. Okay, on that that is Boolean algebra, set is 0 or 1. Only we will consider 0 1. We just apply two operator, plus and a minus. Okay, very simple way. Let's see here. If we go through this one, then very different ways also we define these values. Okay, what are those values? We will see, like x y. Okay, here 0 0 1 1 0 1 0 1. Then obviously if we multiplication, so then what happens, the value 0 into 0 0, 0 into 1 0, 0 1 into 0 1 1. Whenever two values are true or 1, then x multiplication operator use, then value will be this, like this. Okay. Another way, if we go through that another way also, we can define here very simple way. I just define here. Okay, like here we can write that is x plus y. If x plus y, then what happens? 0 plus 0 0, 0 plus 1, 1 plus 0 1, 1 1, like this we can also consider in this way. Okay. And if we go through x complement only complement, then what happens? 0, here only 1, here is 1, here is 0, here is 0. Okay. So no problem. So these are the some application also we apply on this particular Boolean algebra. Now we define different there is postulates with the example in different ways. With a certain example, we will see that how it is working. Okay, different examples also we can take it. Okay, so now we see different examples of Huntington postulates. What are the examples are available? We will see those examples also we will consider. We know that the closure rule of under Huntington, that means the structure is closed with respect to two operators, which is obviously from the table, particularly some certain rule, it is satisfied certain rule, since the result of each operation is also either 0 or 1 or 1 or 0, like this. In that case, what happens? Closure rule, whenever you go through closure, okay, closure rule, that means 1 0 belongs to B, for example. When you apply any two operators, then it will be satisfied, which is belongs to that both belongs to B B set, either multiplication or addition. If not satisfied, then that is not close to the particular operator. Okay. Another concept also we can consider, like a identity element. Okay, identity element, we know that either 0 or 1. 0 for addition. Okay, 0 for addition and 1 for multiplication. Okay, 1 for multiplication. Now you see, very simple way we can define. Okay, 0 plus 0, suppose we consider 0, very simple. 0 plus 1 is equal to 1 plus 0, that is 1. Okay, very simple way. Addition property, identity element, 0 is the identity element. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1 plus 0 is equal to 1. Simple way, because we just consider 0 1 belongs to one set, through that we can consider. Okay. Otherwise, multiplication concept point of view, 1 into 1 is equal to 1, or 1 into 0 is equal to 0 into 1 is equal to 0. Okay, that is also belongs to B set. So two identity elements, that is 0 and 1, used for that is addition and subtraction, is defined in this way. Okay, identity elements. And cumulative laws also we can define previously, that is you can tell as a symmetric of that. Now we will see that is a distributive. Okay, distributive law under that Huntington, how it is defined, very simple way we will see. So we will see different postulates at the particular this part, very simple way, but it is necessary to draw the table, very simple way we will see. One is x part, y part, z part. Okay, that part is equal 1 2 3 4 5 6 7 8 9. One is x, y plus z one part. Okay. One is x part, y part, z part, y plus z. Next is x into y plus z. Next we can draw like this. Very simple way we define x dot y. One part is x dot y, another part is I will show you, that is x dot z, x dot y plus x dot z. We will prove it. This property and this property will be same. How it will work, that I will see. So now I will see how it will work. Here very simple way, 0 0 0 0 4 0 4 1 1 1 1 1 1 2 3 4 1 2 3 4 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. Okay. Now we will see y plus z. Y plus z, very simple, 0 1 1, it is also 1 0 1 1 1, y plus 1 z. Next x into y plus z, this part and this part. We will see what is the data, what value we consider. Okay. So 0 into, it is 0 0 into this part 0, this is also 0, this is also 0, this is also 0. Since it is 0, all part is 0. Next we will see it is a how it is also 0, because 1 0, it is 0, 1 1 1, it is also 1, it is also 1, 3 1, other part is 0. Okay. Now we multiply x into y, these two 0, first 2 is 0, x into y, other also here 0, here 0, here 0, other 0, 0 0 0, this is 1, this is 1. xz, that is up to here 0 0 0 0 0, you see, this is also 0, this is xz 0, and this is 1, this is 0, this is 1. Okay. Now x dot y, okay, x dot y, x dot z we apply. What is the result value? X dot y, this you will just add. What is the result? Result will be, here is 0, here is 0, here is 0 0, here is 0, here is 1, here is 1 1. Now see this is same or not. Okay, up to here 0 0, this is 1, this is 1. So now distributive law, whenever apply for this Huntington postulates, we satisfy, this is proved, distributive law is proved. Okay. Now see other concept of this particular postulates. Okay. What is this? Another is, and other also we can use, that is distributive law, addition over multiplication, multiplication over addition, that is also we can prove, doesn't matter. Now complement point of view, we will see what are the complement point of view. That means x plus x complement is equal to 1. Complement, we can write complement. Okay, you can write a complement, that is x plus complement, x plus x complement is equal to 1. Okay. Normally we will consider in this way. Other way also we can write a 0 plus 0 complement is equal to, you see what is the value of this. Okay, 0 plus 0 complement, suppose x is 0, then 0 plus 0 complement is this one, 0 plus 1, that is 1. Okay, reverse case means x is equal to, when x is 0, this 1, x is equal to 1, then what happens? It is 1 plus 1's complement, that is 1 plus 0, that is 1. Okay, so addition of this complement also satisfy in this manner to find that identity element. It is one case. Another case also we will consider, like x into x dash is equal to 0. Let x is equal to 0, then 0 into 0 complement, 0 into 1 is equal to 0. Very simple. It is also 0. Let x is equal to 1, then what happens? 1 into 1 complement, that is 1 into 1 complement 0, that is also 0. Okay, so both 0 here, 0 and 1 are identity element. Okay, for addition and multiplication. That is we can define in this way. Okay, and another last elements, postulates also we know that is if we consider two values, let us consider 1 and 0 belongs to B value. Okay, that doesn't equal, both two values doesn't equal, 1 never be equal to 0. That is our motto. Okay, if we two elements will consider for any set, then that can never be equal. Okay, that is the main concept of our last postulates of Huntington. So these are different applications also we consider. I hope all of you understand this different applications. Okay, thank you very much. Thank you very much to watch my videos to progress our channel. Thanks to all. So if you like this videos and that is proceed our channel, then you are welcome to my channel. I always explain different problems as per the topics. Okay, so today topic was Boolean algebra with the postulates and certain examples. I completed this one. I hope all of you understand this particular topic. Okay, thanks to all. Please subscribe my channel and watch my videos, and please if you have any comments, please comment on my channel and videos. Okay, thanks to all.